Hello everyone, this is an electronics lecture based on network theory for students studying in Msc.Physics. So this is a network. We know I1 and V1 are the input terms, I2 V2 are the output terms, and in input we have two components, output we have two components. That's why it's called two-port network. From this two-port network, if we want to extract any information or anything about this network, we have to consider some parameters. Parameters are in terms of impedance, in terms of admittance, and in terms of transmission. First of all, let's consider the V1 and V2 are the dependent term, dependent on I1 and I2. That is voltage dependent on current. Let's consider it. By considering this, you will get the equation called equations in terms of impedance parameter. Impedance are ZII. We can vary this I and I, so we can get the ZII as Z11, Z12, dot. So first of all, if you take V1 as dependent on I1 and I2, you will get V1 equals to Z11 plus Z12 I2. Similarly, if you take V2 dependent on I1 I2, you will get V2 equals to Z21 I1 plus Z22 I2. This is Z2. So these two equations are equations in terms of impedance parameter. Now we all know admittance can be taken as 1 divided by impedance. So in case of impedance, the voltage are dependent on current. So if you want to write the equations in terms of admittance parameter, we have to take the currents as dependent on voltage. So we get current I1 is dependent on V1 and V2, and the constant terms are Y11 plus Y12, and current I2 equals to Y21 V1 plus Y22 V2. So these two equations are equations in terms of admittance parameter. Similarly, we can take equations in terms of transmission parameter. In case of transmission parameter, we have to choose the input terms are dependent on output terms. That is, V1 and I1 are the dependent term on V2 and I2. That's why we can write V1 equals to A times V2 minus B times I2. Similarly, I1 is input component, so I1 equals to C times V2 minus B times I2. So ABCD are the transmission components or transmission parameters. Sorry. Now to establish the relation between this impedance parameter and admittance parameter, and impedance parameter and transmission parameter, we have to do some math. First of all, let's consider these two equations. From these two equations, we can write the equation for current I1 that equals to mod of, that is determinant of V1, V2. We are considering I1, so cover this I1 now, and we are left with Z12 and Z22. And at the bottom we have complete determinant of this whole ZII, that is Z11, Z12, Z21, Z22. By bringing this determinant, you will get this term as Z11, Z22 minus Z21, Z12, and we symbolize this whole term as delta Z. By putting this delta Z in case of this determinant, you will get the value for I1 equals to Z2, sorry, this was 22. Sorry, yes, this is Z22. So we have I1 equals to Z22 divided by delta Z times V1 minus Z12 divided by delta Z times V2. And from we can write another equation for I2 also, and I2 equals to determinant of cover this I2, we have left with V1, V2 and Z11, Z21. So Z11, Z21, V1, V2, and at the bottom we have the same Z11, Z12, Z22, 21, Z22. By doing math, we will get the value for I2 equals to Z21 by delta Z times V1 minus Z11 by delta Z times V2. Okay, now let's compare this I2, I1 Z22 divided by delta Z, and we have Z11 by Z12 divided by delta Z equals to Z12. So Y12 equals to Z12 divided by delta Z. And by comparing this I2 with this I2, we get Y21 equals to Z21 by delta Z, and this is Y22 equals to delta Z11. So Y22 equals to Z11 by delta Z. Okay, we have established the relation between Z and I parameters, that is impedance and admittance parameter. Now to establish the relation between ABCD and this Z, we have to consider again this V2 equation. This V2 can be written as I1 equals to, because here we have I1, so we retain this equation in terms of I1. So from this equation we can write I1 equals to V2 divided by Z21 minus Z22 divided by Z21 times I2. Now compare this I1 with this I1. Here we have V2 minus I2. Here also we have V2 minus I2. So we get C equals to 1 divided by Z21 and D equals to, so Z22 divided by Z22 by Z21. Comparing this with this I1. So D equals to this value. Now to get the relation between AB and this Z parameter, we have to put this I1 value in this V1 value, because here we have V1. So let's put this I1 value in this V1 equation, and we have V1 equals to Z11 times V2 divided by Z21 minus Z11 Z22 divided by Z21 I2, and we have plus Z12 I2. Now doing this LCM terms summation, you will get V1 as equals to Z11 by Z21 V2 minus delta Z by Z21 I2. If you do the LCM, take LCM and do the math, you will get delta Z by Z21. And delta Z is nothing but Z22 Z11 minus Z21 Z12. Now compare this V1 with this V1. Here we have V2 minus I2, V2 minus I2. So we have created the relation, that is A equals to nothing but Z11 divided by Z21, and B is nothing but delta Z divided by Z21. And I think I have done one simple mistake, that is whenever we have considered the equation in terms of determinant, let's check in your copy that here we have plus term, but Y12 will be equals to negative of this term, and similarly Z22 will be equals to negative of this term. So you will correct this in your copy. Finally, we have established the relation between this impedance parameter with the admittance parameter and with the transmission parameter. So we are all done. Now one has a single relation called reciprocal circuit relation. What is reciprocal circuit? If you feed the input in the output, you will get the reciprocal circuit. And in case of reciprocal circuit, we have the property that is Z12 equals to Z21. This is the property should be obeyed by any reciprocal circuit. So if this is the property, our delta Z value will be changed. Delta Z value will be changed as Z22, Z21 and Z11 minus, here we have Z12 minus Z21. So we can write Z12 as Z21, or we can write Z12 as Z21. That means here we have Z12 square, or we can write this delta Z equals to Z22, Z11 minus Z21 square. So this is the value of delta Z in case of reciprocal circuit. Now you may be asked in exam to calculate what is the value of this AD plus minus BC. This value is nothing but 1. So remember this, and we can calculate this value easily. So let's take AD. A equals nothing but Z Z11 by Z21 and D is delta Z by Z21 and plus minus we have B times C. So B is D value is Z22 by Z21. This is not delta Z, Z22 by Z21 and plus minus B is nothing but delta Z by Z21 and C is 1 divided by Z21. If you open this delta Z, you will get Z11, Z22 minus Z11, Z22 divided by this term, that is Z21, Z21. We will just calculate the delta Z. So this is this. Sorry, here we have Z12 and Z21. And in case of reciprocal circuit, we can write Z12 as Z21 or Z21 as Z12. So let's change this Z21 with Z12. Because in reciprocal circuit, these two are same. Here mentioned it. So from here, this whole term give value 1. And if you take this sign as positive, in that case, you will left with AD plus BC. We are considering this symbol as plus equals to twice of this term. And Z11 by Z21 is nothing but A and Z22 by Z21 is nothing but D. So we have twice of AD here and here we have minus 1. By rearranging this equation, we will get AD minus BC is equals to 1. This is proved. And if you take here the negative sign, so this is, if this is negative, this term and this term will get cancelled out and this negative will multiply with this negative will get plus. So we have finally we will have the same equation, that is AD minus BC equals to 1 because we have taken negative sign here. So we have put AD plus minus BC equal to 1 always for reciprocal circuit. Now there are some short circuit conditions in this two-port network. What are those? Those are if our current and voltage are get 0. That is, if your current I2 equals to 0, from this equation we can write this V1 divided by I1 equals to Z11. Sorry, this is not Z11. We have to symbolize this by another symbol. That is, we symbolize this by Z, and this term is input terms. V1 and I2 are input terms. So Zi represents input, and the output we have I2 equals to 0. How we make I2 equals to 0? We have to make the output as open circuit, because whenever there is open circuit, there will be no flow of current. So we symbolize this term as O. O means output is open. Also, we can have V2 divided by I2 when I1 equals to 0, and we symbolize this by J. This I2 and V2 are the output components, terms. So we write O means output terms, and input we have current 0. Current 0 by open circuit, so symbolized by O, open circuit. Similarly, we can have this V2 divided by I2 when this V2 by I2 when V1 equals to 0. How will you get V1 equals to 0? If you short circuit the input, if you short circuit the battery, you will have 0 voltage. So in source, if you have 0 voltage, you symbolize this by Z. These terms are input, output terms. So ZO, and how will you make V1 equals to 0? By short circuiting. So A represents short circuit. Similarly, we will have V1 divided by I1 when we have this V2 equals to 0. How we make V2 equals to 0? By short circuiting the output, and we symbolize this by this term as input terms and output is short circuit, so S. So ZIS, ZOS, ZOO, ZIO are the impedance in case of short circuit or open circuit case. Now to establish this short circuit and open circuit impedance in terms of our taken impedance parameter, we have to do some simple math. That is, so to start, so the simple math is nothing but we have to consider this equation V2 and we have to take V2 equals to 0. So this V2 equals to 0 and we have the equation for current I1. Sorry, current I2, because we have to put this I2 value in equation once I2 value. And if you put this I2 value here, there we have also the I1 and taking common I1 and multiplying with this left hand side, we have V1 divided by I1 when this V2 equals to 0. And we have the same condition here, V1 divided by I1 when V2 equals to 0. So we are going this way. So from this equation, if V2 equals to 0, this equation V2 equals to 0, in that case we have I2 equals to negative Z21 by Z22 times I1. Am I right? Okay, this Z21 I1 negative by Z2. And if you place this I2 value in equation 1, we have, so from this equation 1, if you put this I2 value, we have V1 equals to Z11 I1 minus Z21 Z12 I1 by Z22. Now let's do this math and we create V1. V1 is nothing but delta Z I1 divided by Z22. Because this Z22 Z11 multiplied and we know this delta Z is Z11 Z22 minus Z21 Z1 and we have I1. So we have V1 equals to this. So take this I1 the left hand side and we have V1 divided by I1 when this V2 equals to 0. So this is V2 is 0. This is nothing but delta Z divided by Z22. You see this V1 divided by I1 when V2 equals to 0 and this V1 divided by I1 V2 equals to 0 are same. So we can write this ZIS is nothing but this. That is ZIS equals to this now delta Z divided by Z22. So we have established the relation between this term with our impedance parameter terms. Now if you consider the first equation, that is this is the first equation. In this equation if you put V1 equals to 0, so V1 equals to 0 and take the value of I2, because we have to put this I2 value in this equation 2 such that we will get, we have to take the value of I1 from equation 1, because we have to remove this I1 and take this I1 as I2 by taking I2 and I2 common and taking the left hand side, we will get the equation for V2 divided by I2 in case of V1 equals to 0. So let's do that. From this first equation we have I1 is nothing but negative Z11 divided by, we are calculating the value of I1. So I1 is nothing but minus Z12 divided by Z11 times I2. So this is the value of I2 from this equation when V1 equals to 0. Okay. So if you put this I1 value in this second equation, you will get V2 equals to Z21 minus Z12 divided by Z11 I2 and we have plus Z22 I2. Now this Z11 will be multiplied with Z22 if you take the LCM and do the math. So we have the value of V2 equals to delta Z divided by Z11 times this I2. And if you take this I2 to the other hand side, we have V2 divided by I2 when V1 equals to 0, this. So we have get the value of V2 divided by I2 when V1 equals to 0 as this. So this is the second relation for impedance parameter with the taken short circuit and open circuit case. And other two relations can be made very easily. That is, if you consider the first equation and take I2 equals to 0, you will get V1 divided by I1. When this I2 equals to 0, I2 equals to 0, this is nothing but V1 divided by I1, I2 equals to 0 is nothing but Z11. So this is the equation, that is Z I2 is nothing but Z11. And from this equation, ZOS is nothing but delta Z by Z11. Similarly, here ZIS is nothing but delta Z by Z22. And from this second equation, if you take I1 equals to 0, you will get, so I1 equals to 0, that is V2 divided by I2 is nothing but Z22. When I1 equals to 0, so you establish the fourth relation. That means this ZOO is nothing but Z22. So these are the relations, and this one. These are the four relations between our taken impedance parameter with the short circuit and open circuit cases impedance parameter. So that's all can be done in a single lecture for students studying in Msc.Physics. I hope this video will be very helpful for you. If so, feel free to like this video because that will be very helpful for me. And feel free to give any recommendation or any problem you are stuck with. I will try to do my best to resolve your problem. And if you want to know anything about physics or anything related to physics, you can subscribe to my channel. Thank you.